welcome everyone. Thank you so much for coming to this talk, Adaptive Socio-Technical System with Architecture for Flow. I hope you can make yourself comfortable, and I apologize for my voice. I didn't drink whiskey. It's just a little cold. I'm sorry about that. So, just start. So when building systems in general, we are facing the challenge between building the right thing and building the thing right. So building the right thing addresses effectiveness and addresses questions: how aligned is our solutions to our user needs? Are we generating value for our customers? Have we understood the problem, and do we share a common understanding? Building the thing right, on the other hand, focuses on efficiency, for example, efficiency of engineering practices. And it's not only crucial to generate value for our customers, but also being able to deliver that value to our customers. And how fast can we deliver changes, and how fast and easy can we make a change effective and adapt to new circumstances? So the one does not go without the other, but as Dr. Russell Eckhoff, one of the pioneers of system thinking movement, stated, doing the wrong thing right is not nearly as good as doing the right thing wrong. So building a wrong product, even in an efficient manner, is still worse than building a right product inefficiently. Or as John Cutler says, crap delivered quickly is still crap. Unless we learn something from it, and we might also act on that learning. So to build the right thing right, we need to build adaptive socio-technical systems that are optimized for fast flow of change and constant feedback. And one approach out of many that I would like to share with you today is by combining Wardley Mapping, Domain-Driven Design, and Team Topologies as architecture for flow. And you might ask how to bring those tools together. And I said, well, great question. So because I built I developed an opinionated, to be honest, an opinionated structured approach as visualized as an architecture for flow canvas, and which I would like to share with you today. And this architecture for flow canvas that reflects assessing your status quo, your as-is situation, and also designing your future to be situation as well. And this canvas is not a rigid framework. Instead, it's just provide as little structure as possible, and can also be complemented with other techniques on demand as needed as well. So it typically starts with the teams of today, and then also envisions the teams of tomorrow. And when we start with the teams of today and their way of working, what we typically do is we describe the current teams and how they are organized, how the teams depend on each other in their flow of work, and how do they interact, and also how big are the current teams in terms of like the team sizes, and what parts of the system do they currently own. And these insights, we are going to use this as a foundational starting point later on when we transition to the envision to be situation. So coming from the team overview, and the next step is also to assessing our current flow of change. And to build the thing right, we need to optimize for a fast flow of change, where a piece of work or piece of change flows through our system from idea to delivering value to our customers through our system with minimal interruptions and minimal bottlenecks. And to optimize for a fast flow of change, this involves assessing our current flow of changes and also identifying what currently blocks our flow and what we want to minimize. But also involves identifying what works well in our flow, what supports our current flow, what we would like to keep. So analyzing those blockers to flow can be done from various perspectives. So if the teams do not fully own the entire end-to-end flow from designing, building, testing, releasing, and running the parts of the system they are responsible for, then those teams depend on other teams' activities and tasks to get their own work done. and need to repeatedly hand over work to other teams at an earlier or later stage of flow to get their own work completed. But handover requires a high amount of coordination and communication efforts between multiple teams, and potentially also introduce wait times between multiple teams and also affecting our flow of changes. And if teams are missing capabilities in terms of skills, and need to bring in people with a specific expertise, so those experts then do something in order to get our own work completed, that can also impede our fast flow of change, particularly when those people with a specific expertise are not available when we need them. And every dependency requires some level of communication and coordination efforts between multiple teams, and also increases the probability of wait times and delays. Particularly when the people we depend on are not available when we need them, or when the teams we depend on, when they can't keep up with their demands placed on them, when they are overloaded, so that those other teams that we depend on are becoming a constraint and slowing down the overall performance. So if teams have to interact with many other teams to get their own work completed, that is potentially slowing down our flow of change. And from a software architecture point of view, with a tight change coupling, for example, in a monolithic big ball of mud, that also impedes our flow of changes, particularly as changes in one part of our system can have unpredictable side effects on other parts of the system, which then increase the risk of breaking things and also introducing defects and rework. And from a software quality perspective, also technical debt, poorly written code, lack of tests, pattern violations, code complexities, that leads to fragile code bases, and that is hard to maintain. In a messy architecture and with a blurry model and fuzzy boundaries, that makes it really difficult to establish clear ownership boundaries. And that leads to lack of clear ownership, which decreases the accountability, then potentially leading to not my job syndrome. And that can also cause decision delays and impeding our flow of change. And with business logic mingled together in a messy model and with no clear modularity boundaries, that also could increase our mental effort to understand a piece of code, including grasping all the dependencies in a large intertwined system. And that also could lead to teams owning too many or too large parts of our system. And when teams own too many or too large intertwined parts of our system, involving also a high level of technical debt, that is then potentially the team's cognitive load is going to exceed. And if the team's cognitive load is largely exceeded, that also becomes a delivery bottleneck. And when teams lack priorities and focus, they often try to work on multiple tasks at once, and resulting then in higher work in progress and jumping between multiple tasks without completing them. And frequent interruptions, unplanned work, this is leading then to a high amount of context switches, which is then also impeding our flow of changes. So after we have addressed the current teams with their structure, their responsibilities, and also identified the blocker to flow, the next aspect is that we also need to understand the current business landscape, including also the user perspective. To build the right thing, the effectiveness aspect, that requires to start from the user perspective. Clayton Christensen, the inventor of the Jobs to be Done theory, he stated that people buy products and services to get a job done. In order to help users to get their job done, we need to know who our users are, but also what kind of outcome they want to achieve in order to get their job done as user needs. And jobs to be done and user needs, they are representing the problem space and remain the same solution agnostic. So they usually don't care if you are going to solve their problems in a shiny AI mechanism, shiny AI technologies, as long as you fulfill their user needs. So in the example of an online school solution for junior students, one of the user types could be the teachers. And the teacher's core functional job is to facilitate remote learning. And to accomplish this job, the teachers need to prepare learning material, they need to assess the students' understanding with assignments, they need to track the students' progress over time, and also facilitate communication with students and ensure and set up a secure access to the learning platform, for example, through sign-up and sign-in processes. So, in the solution space, these user needs are directly or indirectly fulfilled by a chain of components that generates value for our users by satisfying these user needs. And that's why we can blend in the value chain, the y-axis of our Wardley map, where the users and user needs are representing the anchor of our map. And deriving the value chain, that helps us to ensure that we are addressing the right problem and create value that aligns well with user needs. And the value chain itself shows how different components connect in order to generate values and also to visualize the dependencies. And we can start simple. We can start with just a few components and iterate later on. And these components of our value chain are then going to be typically mapped to evolution stages on the x-axis, such as Genesis with brand new things, then custom build, product and rental, such as off-the-shelf products or open source software solutions, and commodity and utility at the right. And each evolution stage comes with different characteristics. So towards the left spectrum, towards Genesis and custom build, the components are changing far more frequently than components on the right spectrum towards product and rental, commodity and utility. On the left, we are dealing with high level of uncertainties, unknown unknowns, and undefined, poorly understood markets. While on the right spectrum, the components become more stable, known, widespread, standardized, and the markets are pretty much well-defined and mature. So a Wardley map itself that visualizes the landscape in which an organization is operating and competing in, but it's also not supposed to be perfect. It just provides a useful abstraction. And a great value comes from creating a Wardley map together within a group. And that helps to create a common understanding of our landscape within that group and also allows us to challenge our own assumptions. It also helps to assess efficiency gaps in terms of, are we custom building components that do not belong to our core domain that provides competitive advantage, or can we utilize further evolved components? So the map helps to identify areas where to invest and innovate and what to evolve and outsource in order to gain competitive advantage. And I personally use this Wardley map as a visual tool that guides through the optimization process by blending in patterns from domain-driven design and team topologies. So coming from the as-is situation with the current teams, their current responsibilities, ways of working, with their assessed blockers to flow, and also with the current business landscape, we are now gradually blending into the future to-be state by categorizing the problem space. And categorizing the problem space means to divide our problem space into subdomains and bridges the status quo, the as-is, and into the to-be situation, the future landscape. So the user and user needs, they are not only representing the anchor of our Wardley map, but also represent the problem domain, and that's where domain-driven design comes in. So who of you have read the blue DDD Bible? Hands up. Yeah, I would say 23.2%. And hands up, keep your hands up. Have you read it to the end? Oh, really? You stay hands up? Amazing. So it took me 4 times, to be honest. So, but it's really wise, but very dense book. So in general, domain-driven design helps us to gain a shared understanding of our problem domain and also helps to partition our problem domain into smaller parts, the subdomains. But not all subdomains are equal. So some subdomains are more valuable to the business than other subdomains. So we have different types of subdomains, such as core, supporting, and generic. So the core domain, that is the essential part of our problem domain, providing competitive advantage, and that is the subdomain we have to strategically invest in most, and that's the one that we should build in-house. The supporting subdomain, that helps to support the core domain and complements the core domain offerings. So the supporting subdomains are not providing competitive advantage, but are necessary for the organization to succeed. And the supporting subdomains, or the solutions of the supporting subdomains, they are typically existing in other competitive solutions as well. So the supporting subdomain, they are non-differentiating, but they are highly specialized. So if highly customizable products or open source software solutions are available on the market, we can look out for buying or using those off-the-shelf products or open source software solutions. But if the supporting subdomain solutions can't be productized because it requires such a high level of specialization, then we have to custom build the supporting subdomains. And generic subdomains, the third type of subdomain types, that are subdomains that many business systems have, not only our competitor solutions, but many other business systems, for example, authentication and registration. So they aren't core, they provide no competitive advantage, but businesses cannot work without them. So generic subdomains are neither specialized nor differentiating. So buying or using off-the-shelf products or using open source software solutions or outsourcing to utility suppliers, that can be applied to the generic subdomains. So the subdomain types help to focus our strategic investment on where it matters most. So to focus on our strategic investment on development efforts on our core domain related bounded context, or let's come to that one in a second, and support us in our build, buy, and outsource decisions. So far, we have partitioned our problem domain into subdomain types, but we also want to achieve modularity in our solution space. When we switch to the solution space, all of our subdomains are currently mingled together in a monolithic big ball of mud with a messy model and no clear modularity boundaries, which is causing tight change coupling, lack of clear ownership, high team cognitive load, and an inefficient focus of development effort on non-differentiating parts of our system that are in total affecting our flow of change and our efficiency. To unlock these blockers to flow, we might want to consider to leverage modularity with high functional cohesion and loose coupling by designing a modular, well-encapsulated, loosely coupled system. And that's where we need to require to decompose our current monolithic big ball of mud online school solution component into modular components, and that brings us to bounded context of domain-driven design. So a bounded context groups related business behavior together, and a bounded context defines where a single domain model can be applied, where a single domain model, which is encapsulating particular business logic of a specific subdomain, where a single domain model can live in. And a bounded context enforces high cohesion and modularity from a business behavior point of view. And they are indicating good themes to split our system apart and also into modular, smaller, modular, well-encapsulated parts. And they also serve very well as ownership boundaries. I come back to that one when we are addressing the team perspective. So designing bounded context and domain models typically involves a close collaboration between domain experts and development teams in order to gain a shared understanding of the domain. And there exists several techniques for designing domain models and the bounded context, for example, event storming, domain storytelling, example mapping, and more. So after we have categorized our problem space into subdomain types, and we have modularized our solution space into bounded context, next is that we are bringing that back to our Wardley map that visualize then our future landscape. And with the previously discovered subdomain types and modular bounded contexts, we can then better target our strategic investment and asking questions such as, are we custom building parts of our system that do not belong to our core domain? And that enables us to focus our major development efforts around our core domain related bounded contexts and providing competitive advantage by building them in-house. And for unspecified or unspecialized non-differentiators, we need to evaluate whether existing solutions can be leveraged. And also, do we have very specialized but non-differentiators as well as, for example, the supporting subdomains, and can those be productized? Do we have available products in the markets? Or do they require such a high level of specialization that they require custom development? But this also creates an awareness that we should not invest too much effort in this part of the system because the supporting subdomain related bounded contexts do not provide competitive advantage. Whether we could leverage further evolved components need to be assessed for the entire value chain, not only for our bounded context, in order to also increase our general efficiency. So in our example, we could decide to migrate our on-premise infrastructure components to cloud-hosted services as commodity in order to close our previously identified efficiency gap. So far, we have unlocked blockers to flow that are related to software architecture and efficiency gaps, but considering the socio-technical parts of our system, we also need to bring in the team perspective to unlock obstacles to flow that are related to team ownership, team dependencies, and also interaction and handover between multiple teams. And that's where Team Topologies can help us with their well-defined team types and interaction modes to derive then the future team constellation. So Team Topologies introduced a set of well-defined team types and a set of well-defined interaction modes. So the autonomous cross-functional streamline teams, they are aligned to a continuous stream of work, focusing on a fast flow of changes. But to be able to focus on a fast flow of changes, to produce a steady flow of feature deliveries, they need the support from other teams. For example, they need support from platform teams, and platform teams support the streamline teams delivering their work and are responsible for platforms that the streamline teams can easily consume. And the platform itself can vary in its level of abstraction. So at a lower level, a platform can abstract away infrastructure, cross-cutting networking capabilities. At a higher level, a platform can also abstract away design system or data platform, machine learning, and so on. So the platform teams, they are providing internal self-services and tools for using that platform they are responsible for. Or the streamline teams can get support from the enabling teams, supporting as internal coaches and help them to identify and acquire missing capabilities. Or the complicated subsystem teams can help support the streamline teams. This is an optional team type, and they are supporting the streamline teams on particularly complicated subsystems that require very specialized knowledge. For example, currently it might be an AI platform, or it could be face recognition, video encoding, and something like that. Or specific mathematical model, for example, in the industry, in the insurance industry. So they all aim to increase the autonomy and reduce the team cognitive load of the streamline teams to enable a fast flow of change in the end. But to arrange this team and this team type is not enough to become effective. How the teams are interacting with each other and when to change and evolve the team interaction is also very relevant for organizational effectiveness. So with collaboration, teams are closely working together over a limited period of time. And it's suitable for example, rapid discovery, for example, when exploring new technology together. But collaboration is meant to be short-lived. X is a service that suits well when one team could use a code library or an API or component or platform that can be effectively provided as a service from another team. And it works best where predictable delivery is needed. Facilitation, that interaction mode come into play when one team would benefit from active help from another team, and this interaction mode is very typical for enabling team upskilling other teams on demand. So coming back to our Wardley map, to optimize for a fast flow of change, we first need to analyze what will drive value and change in our system. And that requires to identify where the most important changes in our system occur, the streams of changes. And the user needs of our Wardley map, they are representing good candidates of customer-driven streams of changes. And so we need to structure our teams and our system around these customer-driven streams of changes, ensuring a fast flow of change where it matters most. And deriving the future team organization also involves also finding then, as the next step, to find suitable team boundaries that align to this customer-driven streams of changes. And as mentioned earlier, the bounded contexts, they serve very well as well-defined ownership boundaries for streamlined teams. So that makes then the bounded context, besides splitting a system apart into modular components, also very good candidates for team boundaries for streamlined teams. And bounded contexts also help us to optimize our cognitive load of the teams. For example, by creating clear ownership boundaries, now we have smaller parts that we can assign to teams, enables us to limit the number, size, and complexity of software system that a single team has to work with. And optimizing team cognitive load, that helps to unlock the previously identified blockers that related to team ownership. To be able to focus on a fast flow of change, as mentioned earlier, the streamlined teams are relying on platform teams, relying on other teams, supporting them delivering their work. For example, they are relying on platform teams that then provide platforms that the streamlined teams can easily consume in order to reduce their own cognitive load. And that requires to identify services that supports a reliable flow of change and can be easily consumed as a platform, providing self-service capabilities, reducing then the team cognitive load of the consumer. So in our example of the online school solution, the infrastructure-related components located in commodity and utility, they are good candidates suitable for forming a platform that can be effectively provided as a service by platform teams. And besides team cognitive load, providing self-service capabilities that aims to make the cross-functional teams of streamlined teams then become self-sufficient, and also eliminates then the blocking dependencies of handover and decrease then the corresponding high amount of communication and coordination effort, including wait times and delays. So when talking about team dependencies and ownership, we can also switch now from the external customer view, where our end customers are using our external product, now to the internal customer view, when we switch to the platform perspectives, where the teams now becoming or representing the users of our internal products, the platform. So switching to the platform value chain makes now the streamlined teams become the internal customers of the services that the platform teams provide. And the streamlined teams have the user needs of provisioning and managing infrastructure, building and testing, releasing, deploying, operating and monitoring the services or bounded contexts they are responsible for. And to fulfill these user needs of the streamlined teams, the platform teams can provide a variety of different platforms that then the streamlined teams can easily consume. For example, providing an infrastructure platform that enables then streamlined teams to provision and manage the infrastructure on demand for their services they're responsible for without reaching out actively to the other teams. And in general, the platform can start very small. It can start with just documentation, with describing standards, with describing best practices or providing templates, and can evolve later into a digital platform with self-service APIs and tools. And then another kind of platform, the build and the release platform, that supports then the Streamline teams to build, test, deploy, and release the services of bounded context, and can build also on top of other various components, such as version control systems, CI/CD pipeline, and more. And as mentioned earlier, a platform can also abstract its level of, can vary in its level of abstraction. So at a higher level, a platform can also reflect a design system that then is there to achieve consistent, well-defined visual language at scale, and the teams owning this design system can then provide style guides, standardized design principles, widget libraries, and more. Or to operate and monitor a service, the Streamline teams, they require dashboards, alert mechanism, incident management, observability capabilities, and these capabilities can be provided by the platform teams as operation and monitoring platform. So the platform teams can provide a variety of easily consumable platforms satisfying now the user needs of the Streamline teams to make the Streamline teams then self-sufficient and supporting them delivering their work. And another aspect to consider for optimizing for flow is to identify and close capability gaps, skill gaps. So that's where the enabling teams can come in. So the cross-functional Streamline teams, they need to cover a wide range of capabilities and skills, such as software design and architecture, application security, user experience and accessibility, testing, QA, also software development, of course, and much more. So that is a lot to cover, and where then specialists of the enabling team can be pulled in on demand and upskill then the Streamline teams as needed to make them self-sufficient at the end. But also the enabling team can also facilitate as internal coaches the platform teams by coaching them about how to improve developer experience of their platform, or how to design a scalable, reliable, and secure platform. And plus, the enabling teams can also coach on Streamline teams and platform teams on skills that are related to product management, effective communication, and good documentation, and improvement of practices such as team coaching and mentoring. So the enabling teams facilitate as internal mentors and coaches and help to upskill the Streamline teams on demand, and also the platform teams, so that they become then, the Streamline teams and platform teams become self-sufficient, which then unlocks the dependencies on people having a particular expertise that need to do something before the teams can complete their own work. So the previously collected blockers to flow from the as-is situation can now be revisited and reviewed to determine which of those blockers have been mitigated with our envisioned to-be state. So we could unlock our monolithic big ball of mud with a messy model and fuzzy modularity boundaries by establishing a modular, well-encapsulated, loosely coupled system with bounded contexts. We can focus our development efforts on differentiators that provides competitive advantage with subdomain types and also bounded contexts. We could close our efficiency gap by utilizing further evolved components for the entire value chain, not only the bounded context. Bounded context helps also to provide clear ownership boundaries and help to unlock the lack of clear ownership. And modular, well-encapsulated bounded context, they also enables to limit the size, number, and complexities a team has to work with, and helps to optimize for team cognitive load. And with cross-functional autonomous Streamline teams that now fully owning the entire end-to-end flow of change, and also with In addition, with platform team providing self-service capabilities, we can then also mitigate the dependencies on other teams' tasks or activities and to complete their own work, and can also reduce handovers, wait times, delay, communication and coordination efforts. So, and with enabling teams as internal coaches, upskilling teams on demand, that reduces the dependencies on other people or teams with particular expertise. So bringing these tools together helps us to build the right thing right. So, but after having designed the envisioned after having assessed the current as-is situation and envisioned the future-to-be situation, the next step would be addressing the transition itself. So that's where the architecture for flow canvas stops. But we can also then get some next step, how to transition from as-is to be. And we can transition with a first team approach as the reverse Conway maneuver as one example. And Conway's law states that the organization designs systems that mirror their own communication structure. And the reverse Conway maneuver suggests to restructure the organization first, so to achieve then the desired architecture as an outcome. And we can start with the teams and the landscape of today, and apply the reverse Conway maneuver through incrementally, dynamically retaming in small steps. And it's not just enough to organize our teams and then hope something useful will follow automatically. So we also have to have a clear vision with a to-be situation, what we want to achieve. And we also have to touch and adjust our current system, for example, with incremental replatforming and refactoring. So it has to be aligned, so that they go hand in hand. If we leave out one part, the transition will not lead to an optimized fast flow system. And this also can also be supported by evolution of team interaction modes. So the interaction mode between teams, the new formed teams, platform and streamline teams, they can change during our transition and support our transition. So for example, from going from close collaboration to X as a service, and then also going into facilitation mode of the new formed streams. And also changing the teams and the system in small increments and small steps that also allows us to gather early and constant feedback that we can also feed in adjusting our to-be scenario and refine our to-be approach accordingly. So with the reverse Conway maneuver, dynamic reteaming, and the evolution of Team Topologies interaction mode, we are now able to transition into the to-be envisioned to-be states and also enables us to unlock a variety of blockers to flow. So as a summary, it's the combination of Wardley Mapping, domain-driven design, and Team Topologies that helps us to generate sustainable value that is aligned to user needs. It helps us to unlock blockers to flow. It helps us to focus our development investment on our differentiators, providing competitive advantage. It helps us to close potential efficiency gap in aligning our teams and evolving their interaction to the system we build and the strategy we plan. And this combination, in my humble opinion, provides a very powerful tool set to design, build, and evolve adaptive socio-technical systems that are optimized for a fast flow of sustainable value and also incorporating constant feedback, and that also allows us to thrive in the face of constant future rapid changes as well. And it helps us to build the right thing right in the end. So I collected some resources that you can also dive in. So I'm providing the link to the slide deck at the end of this presentation. And there's coming a book out soonish. And thank you so much.